Hello, suppose I'm an elf on the North Pole. Forget about the sun for a second and think about an imaginary sphere called the celestial sphere of my perspective. Directly above me is called the zenith, while directly below me is called the nadir. This is true for anywhere on Earth. So, as Earth spins, how does this celestial sphere spin on the North Pole? It spins horizontally, of course, as I'm on the top of the world, you could say, spinning. The North Celestial Pole, roughly where Polaris is at my zenith, while the South Celestial Pole is at my nadir. The Sun spins around the middle at the celestial equator. This is how the Sun moves at 0 degrees altitude. This is the default number, you could say, at the North Pole. And going up or down by 0 degrees, the sun moves. But as we have learned, that's only the default setting during the equinoxes, when the sun is above the equator. During the June solstice, the sun moves 23.5 degrees north towards the North Celestial Pole. So the sun spins around me at 23.5 degrees altitude. During the December solstice, the other extreme happens. The sun moves 23.5 degrees towards the South Celestial Pole. So, the sun spins around me at minus 23.5 degrees altitude. This is also how the stars rotate around me. So, from March to September, the sun is continuously above me. And from September to March, the sun is continuously below me. These are the paths of the sun at the North Pole. During the year, the sun moves from 23.5 degrees north to 23.5 degrees south on the celestial sphere. It shifts by a total of 47 degrees total. The question is, how does the celestial sphere look like? It looks completely different anywhere else. In order to calculate the sun's altitude, we take our latitude and subtract that from 90. Then add 23.5 degrees north or south, whether it's the June solstice or the December solstice, the two extremes. As a simple example, let's take 40 degrees north. The celestial North Pole is thus 40 degrees north. So 90 minus 40, that's 50. That's our default number. The sun travels up or down at an angle of 50 degrees. The sun will be 50 degrees high on the equinoxes. On June, we add 23.5 degrees to the north, so 73.5 degrees. That's the sun's altitude at noon at the June solstice. On the December solstice, we subtract 23.5 degrees from the default number of 50, so 26.5 degrees. That's the altitude of the sun at the December solstice at noon. It's the same as the North Pole, but the celestial sphere shifted 50 degrees south. Anytime during the year, the sun's declination is between 23.5 degrees north and 23.5 degrees south, as the subsolar point migrates from the Tropic of Cancer and the Tropic of Capricorn. On the bottom, the degrees are reversed, like so. So, anywhere on Earth, the sun shifts 47 degrees in total throughout the year. These are the paths of the sun on a daily basis. During June, the sun is above the surface for longer. It rises in the northeast and sets on the northwest. During December, the sun rises in the southeast and sets in the southwest. That's how the days are longer. Back to the North Pole, these are the paths of the sun to the North Pole. Now, suppose I move south and south. Eventually I reach 66.5 degrees north, the Arctic Circle. Now, I don't have constant daylight for more than 24 hours. Above the Arctic Circle, and you can see the midnight sun looking north. I continue to move south and south as the sun gets higher and higher while the day length variation gets less extreme. I have reached now the Tropic of Cancer. We're 23.5 degrees north. I move south to the equator, where the sun is above me on the equinoxes, and I have to look north in June and south in December to see the sun. The days now are always the same length as the nights. If you live in the tropics, on certain parts of the year, you'll have to look north or south to see the sun at noon. If you live above the Tropic of Cancer, you'll always have to look south. If you live below the Tropic of Capricorn, you'll always have to look north. As an example, if I stand on 10 degrees north on June, I'll still have to look north to see the sun, because the sun is above me. The sun is above the Tropic of Cancer. Suppose I continue moving south, and the situation is reversed now, as the sun continues going north, so now it gets lower. At the Tropic of Capricorn, the sun is above me during December. Above the Antarctic Circle, I can see the sun at midnight looking south as the day length variation gets more extreme. The days are longer in December now. At the South Pole, the sun moves horizontally, just like the North Pole, but in the opposite direction, counterclockwise, right to left. On the North Pole, it's clockwise, left to right. Okay, so we have covered the globe. Now, as an example, let's calculate the sun's altitude at a random place at a random date. Say 36 degrees south on the 21st of April. Okay, so 90 minus 36, that's 54. That's the default number at the equinox. Because it's between March and September, the sun is going to be between the equator and the Tropic of Cancer. As it happens, on the 21st of April, using the standard migration, the solar declination is 12 degrees north, roughly halfway, 12 degrees north. So we add 12 degrees north to 54. Here, it's lowering the sun's altitude to 42. The sun's altitude is 42 degrees looking north. This makes complete sense, as I'm 48 degrees south of the solar point, which is at 12 degrees north. Subtract 48 from 90. The answer to the question and everything, of course, is 42. So, those are the sun's paths and how the sun moves every day, how it changes from place to place, and how it changes throughout the year.